Here's pre-calc. This is your little mini lecture for chapter 6.1.1. And we're going to learn the law of sines today, and we're going to derive the law of sines. And so if we would have been in person today, we would have given you a problem like this one and said, hey, I want you to solve the triangle. Solving the triangle means find all the three angles and all the three sides. Well, so you may remember law of sines from last year, or you may not. So I did, well, the first thing you're going to do is get this angle, right? You just go 180 minus 74 minus 39, and this ends up being 67. So, but to get these two sides, we have a problem, because normally we would use our SOHCAHTOAs, right? But we can't, because there's no right angles. So this is a case where you'd want to use law of sines, or you could use law of cosines. So I started doing this problem, trying to get all the sides, and you can see that I had to break the triangle up into little pieces, and I had to do a bunch of SOHCAHTOAs just to find one part, and I kept having to drop these altitudes down, and I even end up, I think in the end I would have to actually find this little piece and then find this little piece and then add them together to solve the whole thing. So that is not the best way to solve a triangle that, a non-right triangle. I mean, SOHCAHTOAs are great, but we would rather use the law of sines. And you might remember a little tiny bit about the law of sines from last year. Law of sines says that there's this relationship. We know that the sides, this is the biggest angle of the triangle, so I know that's going to be the biggest side. And this is the second biggest angle, so that's going to be the second biggest side. And this is the smallest angle, so that's going to be the smallest side. And so there's this proportionality here. So, and how do you use it? Well, I would just say something like, let's see, I want to know what, this is little a, isn't it? And this is little b, and this is little c. So I need to find little a and little c. So what I do is I start out and I find I call it a pair. I can start out with sine of b over b, and then I can pick another pair to find. I'll say equals sine of a over a, and then I can just fill in the numbers. Like sine of b, so sine of angle b is 67 is to 17, as sine of a is to a. We don't know what a is yet. And then we can cross products. So a times sine of 67 equals 17 times sine of 74. And then I can divide both sides. And this is just, I'm just using the law of sines right now, just to show you how this is an easier way to find the side lengths of the triangle than chopping it up and using SOHCAHTOAs. So now I can just say 17 times sine of 74, and then whatever that is, which I already did all that hard work up here. Oh boy, didn't I? I spent a lot of time on all this junk. Divided by sine of 67. So then I get that side A is 17.75-ish. And then I can do it again. I'll just pick another angle pair. So I'll just say, well, I like this angle pair. I want to use this angle pair because I call it an angle pair. I don't know. It's an angle that we have a side across from it. I want to use sine B over B. So it's going to be sine 67 over 17. I want to use that one because it's not a rounded number. And then I'll go sine of 39. See, here's another little pair. over c. And then you just do all this hard work again. Well, it's not that hard. You say sine of 67, c times sine of 67 equals 17 times. And then I can divide. And then so c is going to equal whatever my calculator says that is. So 17 times sine 39 is that, divided by sine of 67. And I got 11.62. And I know that looks like I did a lot of work, but it's way easier than the chopping, because I gave up on this one. I never even found that side. The chopping up of the triangles is not as efficient as the law of sines. But that was last year, or in integrated 3, that we learned how to do law of sines. So now I think I'll make a part 2 of this video. We're going to learn how to derive the law of sines by actually chopping it up, like I said was such a horrible experience for me up here. But we are going to chop up one triangle one time to derive this law of sines. And so that'll be in part 2 of your lecture videos.